This is the e-learning module on correlation and regression. In this module, you will learn about the following concepts and skills. What is meant by bivariate data? How can we use a scatter diagram to represent a set of bivariate data? What is meant by an independent and dependent variable? What is linear regression, and how can we use a regression line to carry out estimation or prediction? What is the product moment correlation coefficient, and how can it be used to measure the strength of linear relationship for a set of bivariate data? What is meant by interpolation and extrapolation? How do we determine the reliability of an estimate obtained from a regression line? How can we carry out a square, reciprocal or logarithmic transformation to achieve linearity? A set of data consisting of the values of two variables, say x and y, obtained from the same sample, is known as bivariate data. Some examples of bivariate data include amount of advertising time for a product and number of sales for that product, heights of a group of people and their ages, mathematics test scores for a class and their English test scores. When a set of bivariate data is plotted in the Cartesian plane, a scatter diagram or scatter plot is produced. Since a set of bivariate data is inherently the sample comprising a discrete and finite number of data pairs, its scatter diagram comprises a discrete and finite collection of points, which are conventionally marked by dots or crosses in the xy plane. In a set of bivariate data, one of the two variables may be affected or influenced by the value of the other variable, which is controlled. In this case, the variable whose values have been controlled is called the independent variable, while the other variable is called the dependent variable. For example, in the set of data on the amount of advertising time for a product and number of sales for that product, the amount of advertising time is the independent variable, while the number of sales for that product is the dependent variable. Let us now look at an example that illustrates the concepts that have been discussed thus far. In a city, the number of outlets for a particular cafe, X, and the number of car accidents, Y, are recorded over a period of time. The set of data obtained is given as follows. Part 1. Sketch a scatter diagram for this set of data. Part 2. Using the scatter diagram, describe a possible relationship between the two variables x and y. Part 3. Explain whether the relationship you have observed in Part 2 suggests that one variable directly causes the other variable. Part 4. If x and y represent the following variables, state whether or not one variable depends on the other, and identify the independent and dependent variables when it does. Time passed, x, and concentration of a substance in a solution, y. Temperature, x, and wind speed, y. Mathematics test scores, x, and English test scores, y.